Let's solve the problem of rates of change. The problem says the gross national income (GNI) of a certain country in billions of US dollars can be approximated by this function f of t, so it's a function of the time, let's see, t is the time, equal 1000 multiplied by e to the power 0.14t, where t equals 0 corresponds to the year 2000. So it means that t equal 1 corresponds to the year 2001. Find the derivative of f respect to t. That's the first question. And second, at what rate was the GNI changing in 2010? So it means that the rate of change also depends on the time. And they are asking me to compute that in 2010. What value will have this in 2010? Obviously, the rate of change is the derivative respect to the independent variable. In this case, the rate of change of the GNI will be the derivative respect to t. So I'm going to compute, for solving problem A, the derivative respect to t. So it will be the derivative of 1000 e to the power 0.14t. This is the derivative of a constant multiplying a function. So that will be the constant 1000 multiplied by the derivative of the function. This is one rule of the derivative. So it will be 1000 multiplied by the derivative of this. And this is the derivative of e to the power u, a function of t. So I noted that this is not the derivative of e to the power t. So it's not the derivative of e to the independent variable. No, it's e to a function of t. This is a composite function. So this will be solved using the chain rule. So the derivative, remember the chain rule. If y equal a function of u, not a function of the independent variable, a function of u, and u if the function of t, the independent variable, then the derivative of y respect to t will be the derivative of y respect to u, so the derivative of y respect to u, multiplied by the derivative of u respect to t, by the derivative of u respect to t. So this rule is what we need to do for solving this derivative, because this is not the derivative of just t, of e to the power t. That is a function that we know the derivative. No, it's e to the power a function of t. So in this case, what we have is e to the power u. So we have a function f of u e to the power u. And this u will be the 0.14t. So this is actually what we have. So f prime of t will be 1000 multiplied by the derivative of e to the power 0.14t, so the derivative of e to the power u. We know that the derivative respect to f of e to the power x will be e to the power x. So if the exponent is the same independent variable, then the value of this derivative of this function, this special function, the derivative is itself. This is one of the rules of derivative. The derivative of the exponential function is the same exponential function if the exponent is the same independent variable. But in this case, what we have is e to the power u. So e to the power 0.14t. So in this case, we use the chain rule. So we get the derivative of e to the power u will be the derivative respect to u, so e to the power u. But I need to multiply by the derivative of u respect to x, so to respect to the independent variable. So we need to multiply by the derivative of this function u respect to the independent variable. So in this case, that is e to the power 0.14t. So the answer will be e to the power u, so e to the power 0.14t multiplied by the derivative of u respect to t, because in this case we are derivating respect to t. So it will be the derivative respect to t of 0.14t. And this derivative we know that is 0.14. The derivative of t is 1 is a constant 0.14 multiplied by the derivative of t respect to t, and we know that this is the derivative of the identity is always 1, so it will be then 1000 e to the power 0.14t multiplied by 0.14. We can multiply 1000 by 0.14, and this is 140, so it will be 140 e to the power 0.14t. So we know then the first question, the derivative of f respect to t is 140 e to the power 0.14t. This is the rate of change of the g and I, so the rate of change of f at whatever value of t. So if t equals 0, I know that the rate of change was 140 e to the power 0. So it will be 140. In this case, the question is what was the rate of change of the g and I when the value of the time is 2010, or better, when the value of the time equal 10, because t equals 0 corresponds to the year 2000. So to answer question B, we know the rate of change at any moment, we know the rate of change at whatever time, the rate of change of the g and I at whatever time, and now we want to know the rate of change when t equal 10. For 2010, t equal 10, and then we substitute t by 10, so it will be f prime of 10. So it will be 140 e to the power 0.14 multiplied by 10, and then use a calculator for doing that. If you have a software like Geogebra, for example, you can solve this in Geogebra, the derivative, and find the value of the rate of change when t equal 10. And I did it in Geogebra. Using Geogebra, what I need to do is just define the function f of t. In the input part of the calculator suite of Geogebra, just type f of t, so define the function f of t, 1000 multiplied by e to the power 0.14t. After you have this, just compute f prime of t, so the derivative of f. There is another way you can type derivative with capital D of f. Anyway, you can type shorter f prime of t and press enter. Geogebra gives you the value of the derivative. In this case was 140 e to the power 7 over 50. This 7 over 50 that Geogebra has is 0.14 I have here. Multiply by t. And then just substitute f prime of 10 and Geogebra compute the value. In our case, that we are working by hand, so just make a substitution of t equal 10 and then use a calculator. So using a calculator, obviously you are going to get the same number. This is the rate of change of the g and I when the time is 10, so it means in 2010. So, and that's answered the second question of our problem. With this, I finish this video. I hope you have found it useful. Thank you.